here to talk about Elixir code style and reducing the cost of reading code and reducing the cost of writing code, especially in the context of Elixir projects where there's more than one contributor. So, what is the Elixir standard style, and is there an Elixir standard style? Do we largely conform to one way of writing Elixir code? So here we've got two examples, which hopefully you can see. The first example uses two-space indentation, and the second example uses four-space indentation. So who prefers two-space indentation in their Elixir code? Who prefers four-space? Does anyone do anything else? Tabs, perhaps. Three. We got a three, and okay, cool. So other than you, we're pretty consistent here. Cool, so that's good. So like, it looks like there is some sort of standard style being hinted at by at least this room, and hopefully that's indicative of the rest of the community, right? So here's another example. I've got a function with 3 clauses, and it's got a very short body for each clause. I might write them with each clause in one line, as on the top example, or I might write them using the do sugar on multiple lines, as in the bottom. So who might do the first example? Ooh, okay, more than I thought. Who might do the second? Okay, cool. And would anyone do anything else? Ah, oh well. Just leave one in, just for you. Cool, so like we're a little bit less consistent here. So previously there was one person who wanted 4 space, but now there's like a bit more of a mix, including me, who doesn't want comments in the first one. So there's a variety of preferences just in this one room. So presumably there's going to be an even wider variety of preferences in the wider community around the globe. So another example, keyword list delimiter position. We've got a top example that's sort of Lisp style, I would say, where we've got the braces on the same line as the first and last item. And then we've got one I might say is a more C-like style, where the braces get their own lines. So who prefers the first one? A few people. Who prefers the second one? Okay. So even more mixed. We've got even more things that can vary in our code. And then, what about trailing commas? I put a trailing comma here. So that's yet another thing that can change. Another way in which we... No? That's another way in which we can diverge. And I find this particular example of like whether we put the braces on the same line or a different line interesting, because I've seen it change over time. It seems that certain big name Elixir projects preferred the Lisp style, and then there was a point in time when they switched over to the one with them separate lines, which was even more confusing for me because I started with the separate lines and then noticed that people were doing the same lines, switched to that, and then they switched back again, which confused me and my muscle memory. So my point is that everyone in this room has a slightly different style. We're all writing fairly similar stuff, but there's lots of small things that we either consciously or unconsciously do different. And as an extension of this, every code base has their own style. And often a code base might even have more than one style or no style, as different developers work at different parts of the system over time. Does it matter? Does code style make any difference whatsoever? So here I've got 2 similar pieces of code written in what I think to be quite different ways. So the first makes use of as much syntactic sugar as possible, and the second one does not. So on the second one, instead of using a do end block, we've just got a keyword list, unsugared of course, that has a key do that has the body of the block inside it. And rather than using the block sugar, which is writing lines one after the other, we're calling the curiously named __ block _ special form, which is what a block actually becomes when it's desugared. So each line becomes an argument to this function. And we've also put parentheses in every single call. So if you look at def module and use, they've got parentheses on them as well. So if we took these 2 examples and fed them into the compiler, we get exactly the same result. They compile to exactly the same thing, they pass the same AST, they generate the same bytecode, they behave in exactly the same way. As far as the compiler is concerned, these 2 examples are exactly the same. There's no difference between the 2. So the compiler doesn't care. From that point of view, there's no technical reason why you should use one style or another, or even if we should use a single style. So if this is the case, why do we care? Or at least why do I care about code style? Why are there strong opinions here? So I believe that a clear and consistent style makes it easier for humans to read code. And this is really important because compilers are quite easy, but humans are actually really hard. And this is the thing we need to be focusing on. So here's a quote from the wonderful Sandy Metz that I really like. Code is written many more times, sorry, other way around. Code is read many more times than it is written, which means the ultimate cost of code is in the reading. It therefore follows that code should be optimized for readability. Adhering to a common code style saves you money. I really like this. I also like that it says a consistent code style rather than saying the best or a particular code style. So I think that it's more important that it's consistent and thus can become familiar rather than it's my style or the best style, which is clearly my style. So how can we achieve a common code style? How can we make sure that when we've got multiple developers in one project, they all end up producing the same thing, structuring everything the same way? So one thing we could do is use a linter. So linters are programs that inspect the style of your code and report back any style violations you might have written. So a few years back, I wanted this for Elixir, so I wrote one called Dogma, and shortly afterwards another one popped up called Credo. So let's see what would happen if we ran one of these linters on those two examples from before that the compiler says are exactly the same. So this is Credo being run on the first example, and it reports no problems, which is fantastic, right? Now we've got a way of programmatically verifying a style. It's agreeing and saying, yes, this is the correct way to write the code. We found the consistent style. So what happens if we run it on the other one? We still don't get any violations. As far as the linter is concerned, this is also fine. So both styles are acceptable. I think this is a problem. So because we don't have the one style anymore, both of those things can be written in two different ways. The linter gets us closer to being consistent, but it doesn't actually give us proper consistency. And why is this? So it comes down to how linters work. So linters work by having a predefined set of patterns that they're looking for in your code. And if it finds one of these patterns, it says, nope, this isn't okay, and then it reports an error to you. So they're effectively a blacklist saying there's a subset of styles that you can't use. But anything outside of that, that's fine, that's good. Go ahead and do that. So they don't provide a consistent style, rather they give you a slightly smaller number of inconsistent styles. And there are other issues too. So they ban a subset of possible styles, as I said, but they also require manual fixing of the style. So if you've been writing your code and then you run your tests and they all pass, and you want to go push, so you're going to run the linter, and then it says you've got 20 style violations, you've got to manually open all those files, navigate to where the problems are, fix all the errors yourself, run the linter again to see if it's happy, because perhaps you've misunderstood what it wanted you to do. And then you've got to run the tests again, because you've changed code. There's a very real chance that you've made a mistake somewhere and you've introduced a bug. Furthermore, linters tend to be highly configurable. You can make decisions about how you want things indented, or maybe not in Elixir, but maybe whether or not you want to use semicolons. Should you use else with unless, that sort of thing. Which means that time that you've saved on checking for these violations, you just push over to another area which is arguing about exactly what things the linter should be checking for, because everybody wants the linter to be enforcing their style. I want style to be consistent, but I don't want to sacrifice time and ease of writing in order to achieve this. So is there another alternative? Over the last year or so, I've been writing, in addition to Elixir, I've been writing a bunch of Haskell and Rust and Elm. And one thing that all these languages share is a really wonderful tool which helps solve this problem called a formatter. And a formatter is a tool that takes source code and rewrites it in one specific allowed style without any input from the programmer. So after using one of these for a while, I really missed it and I wanted it in Elixir. So I started making my own, which you can see here, called xformat. And so as you can see, it doesn't matter how I structure it. I could do that horrible thing where I squish the entire thing on one line and put semicolons. As soon as I hit save or run the formatter, it ignores all of that and writes it in the way that it deems to be correct. So it's now perfectly consistent and requires absolutely no extra effort on my part. So if you compare them to linters, formatters specify a single correct style. It's perfectly consistent. They fully automate the maintenance of style, and there's zero configuration. So there's no way that they can take any more time from you. So here's another example of the formatter being run. And I find this one particularly interesting for a couple of reasons. First, you can see that in order for a formatter to be worth using, it has to pay attention to how wide the code is going to be. So when we've got the first list as a variable nested inside the other one, it puts it on one long line because that it thinks is short enough to fit on one line. But if we nest them inside the other, it realizes that it needs to break it, otherwise you're going to get an incredibly long line. But it's even smarter than that. It knows that the outside list can be split, so it's flat, but the inside one can be spread wide. And then we get very human-looking, very easily readable code. What's even cooler about this, I realized after using it for a while, is that this is something I would have had to do myself. If I made a list longer, I would at some point go, oh, it's now 130 characters wide. This is getting a bit much. I want to click here, press enter, click here, press enter, and restructure the entire thing. Now I don't need to do this anymore. I just have to put the new content in, hit save, and then it does it all for me. I'm actually doing less work with the format than I was previously. And I've, through lots of video gaming, programming, and all that stuff, given myself slightly knackered hands. And if I can do more with less typing, that's fantastic for me and my health. And I don't really want to work without something like this anymore. So if you're like me, this is the question you're interested in now. How does it work? I think it's very interesting, and there's a lot of information and maybe not so much time. So this is going to be a bit of a high-level crash course, but there's going to be some more links at the end. And yeah, we can talk about it. So there's 3 steps. First step is pass the source code into the abstract syntax tree. So this is the thing that Jose was showing us earlier, where if you put some code into quote, it gives you back this Elixir data representation of the code that you just put in. So we start with that. Step 2, we convert the tree into a printable algebra. More algebraics later. And the third step, we print the algebra in such a fashion that respects the maximum width that we've allowed it. So thanks to Elixir, writing a parser for Elixir is fantastically easy. It's just one line. It's code, string to quoted, pass in a string, and you're done. You've done 33% of the work, and you can go home. This is really fun. You can do lots of really interesting stuff, playing about with this, making macros and compilers and static analysis tools and stuff, so go nuts. The next 2 steps are a bit trickier, and they're mostly the work of these 2 gentlemen here, Philip Wadler and Christian Lindig. So Philip Wadler wrote a paper called A Prettier Printer, which suggested a new algebra-based algorithm for pretty printing source code. And it was written in Haskell, of course it was, which meant the algorithm only worked in Haskell because it needed to be lazily evaluated. And then Christian came along and wrote a new spin on it, which would work for languages that mortals can use that are strict, which was on a camel, but it works perfectly well in Elixir. So the algorithm is actually really simple. It's made up of 6 simple algebraic data types and 2 functions, fits and format. The one that the user is going to be using is format, and fits is just an internal implementation detail of format. So I'm going to go through each one of these data types and see what they represent. Oops. Yes, good. The first one's text, and text is just a string. So if you want to format a string, you just pass it through. A string is already printed. There's nothing to do to it. Easy. So if I print the text 1000, I get back the string 1000. So cons is used to join 2 documents together. So if I have cons of double space and cons of 1000, and I format the whole thing, I get the two strings concatenated together, so I get double 1,000. Line, again, nice and simple. Anytime format tries to print a line, it just renders a new line. So if I use this concat function, which is just a little handy wrapper around cons, if I concat 11 line and 2,222, I get 11 and then a space and then 2,222. So nest is where things start to get a little bit more interesting, and we start to see maybe some benefits over just concatenating strings together. So nest is a form that's used for specifying indentation. And when we try and render nest, we don't actually print anything. Instead, we modify the behavior of the formatter. So if there is a line inside nest, we don't just print it as a new line. We print it as a new line followed by a certain amount of indentation, which is the integer specified by the nest form. So for example, if there's a line within a nest with a value of 4, everything comes after it is indented by 4. So in this example, we've got the first two lines have no indentation, and the third one follows a nest and a line, so it's indented by 1. And another cool thing about nest is that it stacks. So if you have nest 4, and then a line, we have 8 spaces of indentation. So you can see how we can start to use these for nesting structures inside each other. So if I have an if, and another if, and another if, each one of them with a nest of 2, it builds up to 6 levels of indentation. So up until now, algebra still doesn't really give us too much over string concatenation until we introduce break. So break's interesting because it's a non-deterministic form. And what break represents is either a space or a new line. And the way it works is that when it's printed, the format function calls the fits function, says, this next chunk of algebra, will it fit on a single line? So with that list earlier, can I fit this entire list on one line? And if the answer is yes, cool, every single one of these breaks is going to be a space. So it'd be like item space, item space, item space. If it doesn't fit, we're going to put all the breaks in as new lines, and then we have a flat document, and so it fit on the space we've allowed it. So we've got the same document here, concat break world. If we format it with a maximum width of 80, it fits on one line. If we format it with a maximum width of 4, it fits on 2 lines. Easy. So with the algebra we've got so far, we can make a formatter that respects the maximum width, but it's very much all or nothing. So this entire document will be completely wide, as in the middle example, or it will be, the other way around, completely wide as in the first example, or completely flat as in the second example. But if you let a human write some code, they're probably going to pick something in the middle. So they'll put as few number of breaks as possible in order to make it fit within that space they've got. And they're going to selectively pick which breaks they want rather than just the first one. So to do that, we introduced the final algebraic form, which is group. So group allows us to group together a selection of breaks, saying that if any of these break, they have to break together. And when you reach another break inside that, then they can decide themselves how they want to break. So it can be either flat or wide. So this is a little confusing, so here's a slightly more detailed example. So in the top line, here's the code I want to format, and it's going to be formatted with a very narrow width, so it won't fit. Break, I've used with the word break. I've ignored concats, they're not there. And then there's a bunch of text, and then I've represented the groups with angle brackets. So the way the algorithm works, it starts with the first step and says, can I render this entire thing on one line? And the answer is no. Okay, so strip off the top level group, which is the one wrapping the entire thing, and find any top level breaks. So there's that one after the equals. And I'm going to turn that into a new line, and then we get the second example. Does this fit? No, it still doesn't. So we strip off another group, and then we make any breaks that we find there into new lines. And then we've got another document. And does this fit? Yes, it fits. Fantastic. So now we can concatenate the whole thing together and print it. That's it. That's all there is to this algorithm. You now know everything you need to know about pretty printing. And then from then, it's really quite simple. There's not much more to it. You just need to define one really big AST to algebra function, which pattern matches on every single kind of node you can have in the Elixir AST. and then generates a suitable algebraic document for each node of the tree. In my implementation, this is currently about a 1,000-line long function. So it is a bunch of work, but it's conceptually quite straightforward and very easy to unit test because it's just a pure function that does something very simple. And you can immediately see if it works or not because we all know what Elixir looks like. So yeah, I think this is really fun. If you want to know more about this algorithm or pretty printing, I thoroughly recommend you read the 2 papers. I've never read a paper before, but they're both really short and really simple and easy and well worth checking out. Interestingly, the Elixir standard library has nearly an implementation of this algorithm comes in it. So if we print something to the console in IEX, it will wrap lists on multiple lines, and it will split structs to be long. It does this using almost the same algorithm, and it's found in Inspect algebra. So the documentation for that is quite good, and it will also give you some forms that you can play with to get started. And if you want to check out what I've done, go to that GitHub URL. Already had a few people contribute, so please get involved, ask questions, break things, report problems. Yeah, thank you very much. And I feel like this is a really cool project and I really like it, and it's bringing something that I really want to Elixir. And I feel like I've been helped directly and indirectly by many people, such as Philip Wadler, Christian Lindig, the Elixir core team, especially with the stuff that's coming in the next version of Elixir that brings a lot more information to the parser, so we can actually tell things we couldn't tell before from the AST. Alex, who's doing the Google Summer of Code project, making another similar format that uses a completely different algorithm, which is worth checking out. The Honeycomb team. And everyone has contributed to Xformat. Thank you very much.
Thank you. Thank you, Louis. Any questions? We can take like 1 or 2 at most. You have all won a question.
Hey, question. How does Xformat compare to the formatter being developed in the Google Summer of Code, the one by Alex?
Cool. So it uses a completely different algorithm, which is one based off of the macro to string function. And I couldn't tell you what the implications of using the different algorithm are. It seems to be working for him. Not done any direct comparisons with them. I think currently the one I'm working on is a bit more mature. But we'll see how things pan out. It's quite nice having more than one project, right? Because I can, screw up and someone else can fix it. It's fine. But yeah, try them both. See what you think.
So Elixir uses different style for macros and functions. When it's a macro, you don't use parents, and if it's a function, you do use parents. And actually, from AST, you can't know if it's a macro of a function. So how did you address that? Do you just have a list of popularly used macros, or do you really recognize if it's a macro and function at runtime?
So everyone disagrees about this. Everyone has a completely different idea about exactly when you should use parentheses and when you shouldn't. And if it's a macro is a common thing, or maybe it's a particular set of functions or whatever it is. This is one of the examples in which the 2 formatters change. So Alex's formatter does have a whitelist of if I see these functions, def macro, I think maybe like schema, a few other things, then we don't put parens around it. I don't think this is like the optimum way to go about this problem for a few reasons. You're never going to know all of the like macro DSLs people are going to invent, and you can actually define functions with those names that do different things. There's nothing special about them. So I think the approach I've taken, which I'm pretty happy with so far, is to instead try and identify the context in which people would be using a DSL. And the rule I've come up with is if it's in the top level of a block, or if it's in the top level of a file, don't use parens. Because all the things like def macro, schema, all of this stuff is at the top level. There's a few places where it doesn't use parens now, which I think maybe I would want to, but as a very simple, completely deterministic way to make this decision, I'm totally on board with it. But if you can come up with an addition to this, I'm thinking maybe there's a hybrid approach where we default to this, but there's some situations in which we do a different thing. That would be really cool.
All right. Thank you. If you want to ask him when he's off stage, I think we need to wrap up for the next speaker. All right. Thank you. Thank you, Louis.